Okay, welcome to this topic termed simultaneous equation. So we'll learn how to solve simultaneous equation using determinant and inverse of a matrix method. If we don't call it determinant method, we'll call it Cramer's rule. So let's start with Cramer's rule. Okay, if we are given a system of equations of three unknown x, y, and z, that's how the first thing we are going to form three determinants from this. The first determinant, let's label it, let's call it delta. That first determinant is the one that will form using the coefficients as seen, the coefficient of the variables, that's the coefficient of x, y, and z, arranged in this way. So our first row is this, second row, third row. So we write A1, B1, C1, A2, B2, C2, A3, B3, C3. So that's our first determinant. The second determinant is the one that has subscript x. Now how do you form it? We just replace the coefficients of x here, the column, with this, with the constants here. So instead of writing the same thing here, we interchange this one with that, the constants, which is k1, k2, and k3. While others remains the same, b1, c1, b2, c2, b3, c3. So the third one is the one that has subscript y. That same way, we replace the coefficients of y with the constants k1, k2, and k3. So these ones are the same, a1, a2, a3, but this is replaced with k1, k2, k3. So y is c1, c2, c3. So the last determinant is we replace z, the coefficients of z, with the constants. So these are the same. These are a1, a2, a3, b1, b2, b3. But this is now replaced with k1, k2, and k3. So the next thing now, remember, this is just they are all constants. They will give us determinants. So to get what we are looking for, which is x. So x is, we divide the constants, that is the determinant that has subscript x, with the one that has no subscripts. So we now divide each of these by delta. So y is changing the determinant that has this. Finally, z is delta. So whenever you are given system of equation, we'll form determinants like this, depending on number of variables. If it's 5 variables, we need 5 equations. 4 variables, we need it. So let's now solve equation using the method. So we asked to solve this using determinant method. So the first thing is to write our first determinant, the one that will form without the constants, that is the coefficient of the variables, which is 2, 3, 1, 1, 3, 4, 3, 1 minus 2. So let's get the determinant. So remember how we find determinant, choosing any row column. So I'm choosing first row, so I have 2 times the determinant of 3, 4, 1 minus 2, minus 3 times the determinant 1, 4, 1, 4, 3 minus 2. Finally, plus 1, 1, 3, 3, 1. So this is 2 times minus 6 minus 4 is minus 10. Minus 3 times, this is minus 2. Minus 2 minus 12 is minus 14. And finally, plus 1 times 1 minus 9 is minus 8. So we have this minus 20. This is plus 42 minus 8. So which is this minus 28. That's this minus 20 plus 42 is 22. 22 minus 8 is 14. So the first determinant is 14. So let's get the other one. So let's find the second determinant. So we replace the coefficient, the first column, with this. So we have 6, 8, 2. Why these are the same? 3, 3, 1, and 1, 4 minus 2. So I'm using the first row. So 6 times the determinant of 3, 4, 1 minus 2, minus 3 times the determinant of 8, 4, 2 minus 2. Finally, plus 1 times the determinant of 8, 3, 2, 1. So we have 6 times, this is minus 6. Minus 6 minus 4 is minus 10. Minus 3 times, this is minus 16. Minus 8 is minus 24. Plus 1 times 8 minus 6 is 2. So this is minus 60 plus 72 plus 2. So this 74 minus 60 is 14. So we've gotten the second determinant. So let's get for the third one. So let's find for y, the one that has y. So these are the same, 2, 1, 3. So we'll replace the coefficients here with this because of y. 6, 8, 2. Y, this is the same, 1, 4 minus 2. So we'll solve using the first row. So 2 times 8, 4, 2 minus 2. Minus 6 times 1, 4, 3 minus 2. Finally, plus 1 times 1832. 1832. So we open up the brackets. So we'll find the determinant. So 2 times this is minus 16. Minus 8 is minus 14, minus 24. This is minus 6 times minus 2 minus 12 is minus 14. Plus 1 times 2 minus 24 is minus 22. So 2 times minus 24 is minus 48. 6 times 14 is 84, and 1 times that is minus 22. So minus 48 minus 22 is minus 70. 84 minus 70 is 14. So let's find the last determinant, which is, so the last determinant, which is z, is we replace this coefficient with this. So this is 2, 1, 2, 1, 3. This is 3, 3, 1. Why this is 6, 8, 2. So using the same row, first row, so we have 2 times the determinant, which is 3, 8, 1, 2, minus 3 times 1, 8, 3, 1, 8, 3, 2, and finally plus 6 times 1, 3, 3, 1. So we have 2 times 6 minus 8 is minus 2, minus 3 times 2 minus that minus 24 is minus 22, plus 6 times 1 minus 9 is minus 8. So this is minus 4. This is plus 22 times 3, that's 66. So we have plus 66 minus 20. 6 times that is minus 48. So we have minus 4 minus 48 is minus 52. 66 minus 52 is 14. So these are the values of the determinant. So let's find x, y, and z now. Okay, so we've gotten delta as 14, delta s 14. So therefore x is delta x over delta, which is 14 over 14. The answer is 1. Y is delta y over delta, which is 4. That same 14 over 14. We have 1. And finally, z is delta z over delta, which is 14 over 14. So they are all 1, 1, 1. So if you check back the original equation, if we substitute 1, 1, 1, we'll get 6, 1, 1, 1, we'll get 8, 1, 1, we'll get 2. So the answer is correct. So that's how we solve using Cramer's rule or determinant method. Thank you.